Hello student. Today let us start a new chapter, your chapter 10, that is your vector algebra. So you see what is a vector algebra means here we see when we use different physical quantities in our daily life, then generally we are dealing with two different types of physical quantity. One of them are known as scalars and the other is known as vectors. So first you see we have to know what is the meaning of scalars and vector, or what are your scalar quantities or what are your vector quantities. So you see, first I'm going to tell you about the scalar quantity. So scalar quantity means the quantities having magnitudes only are known as scalars. That means there are some physical quantities we are going to use in our daily life which has only magnitude. Those quantities are known as scalars. For example, if you are saying about the length, breadth, mass, temperature, volume, area, time, money, voltage, distance, speed, work done, etc. So in these cases, what happen you see, when I say about the length, যেতিয়া মই এটা length বুলি কওঁ, length মানে তোমালোকে ধৰা মই ক'লো 1 meter. 1 meter in which direction? 1 meter in which direction? Generally, I mean, we are not going to mention. I mean, generally, 1 meter বুলি ক'লে আমি ক'ৰ পৰা বুজো? Just we understand the length of the scale or the length of a, say, thread is 1 meter. Direction is immaterial in this case. So that's why you see length is a scalar quantity. Similarly, suppose mass. Mass means generally we go to the market, suppose, and we buy a kg of sugar. Then sugar means just a weight, just the mass is considered, not the weight. So mass means what? Amount of sugar. So in which direction it doesn't matter. Okay, so that is a scalar quantity. So ami scalar quantity mane ki buji palu? It has only magnitude. Okol yare magnitude to thake, value to thake. Similarly, say money. Money to koleu tumanakor direction or immaterial is not it. So this type of quantities are known as scalar quantities. So these are your different examples of scalar quantities. Okay. Then after that, we are going to this the next type of quantity, that is your vector quantity. So first, again, we have to know what is a vector quantity. First, let me go to the definition. Vectors. The quantities having both magnitude and directions are called vectors. So in this type of quantities, that is in the type of this vector quantities, here we have two measures. One is the magnitude and other is the direction. That means yate okol mantu hole nohobo. We have to know in which direction. Direction is also important. Okay, then this is called the vector quantity. For example, you see velocity. Velocity means here it's a vector quantity because it has magnitude and also it has direction. Similarly, force, acceleration, weight. In weight, what happened? You know the formula of weight is W is equal to mz, where z is the acceleration due to gravity. So if the thing is attracted towards the gravity, it will be positive, and opposite to the gravity, it is negative. So weight is also a vector quantity. Similarly, momentum, displacement, etc. Actually, you see, you are getting in detail about all these terms, you know, in detail in physics. Physics are tumalke quantities bura bikoy details at pohisai. Ami just set examples bur korisu. Okay. Now in this chapter, actually, we are going to deal with the mathematical problems only. So vector hole amar ki hobo lagibo tumalukor magnitude or logote direction to thakibo. You see, you don't confuse it. Suppose for example, mass and weight. Mass is a scalar quantity. It means that is, suppose you are going to buy a kg of sugar, that is a scalar quantity. But weight is a vector quantity. Okay. Now next you have to know how to represent a vector. That is representation of a vector. That means how we are going to represent a vector. So first thing, you have to know it. A vector is represented by a directed line segment. And an arrow mark is given over a vector quantity to distinguish it from the scalars. So you see how to represent a vector. So you have to know it that a vector is represented by a directed line segment. It's very important. You have to give an arrow mark over a line to represent a vector, and it will distinguish then it will be distinguished from the scalars. For example, if I consider this line, say A is a point and B is a point. I'm giving an arrow here from this A. This arrow mark is in this direction from A to B. So this is a vector, okay, because it has an arrow mark. So it is denoted by, generally AB means without any giving any arrow, AB is a line segment. But when I give the arrow from A to B, we understand that the line is started at the point A and it go in the direction of B and reach the position of B. In this direction and reach the position B. So in this case, A is called the initial point, okay, where it is started or starting point, and B is called the terminal point or the end point. So how to represent a vector? You remember it, that a vector is represented by a directed line segment. So you see, if AB is a line segment, then AB arrow, this one, AB arrow is called a vector. Or sometime in short, it is denoted by this way. AB bar is equal to A bar, like this. We may denote it by this way. AB bar is equal to AB. So symbolically, a vector, we have got it that here. Symbolically, a vector is denoted by AB bar. Here A is called the initial point and B is called the terminal point or end point. In this figure, we are going to the figure. So AB bar, just I read it as bar, but actually you have to give an arrow. So AB arrow will represent a vector where A is the initial point and B is the terminal or end point. These things up to date. Now you see, its magnitude is given by the length of the line segment AB. So if suppose AB bar is of measure 2 meter, suppose here I'm considering AB bar is a measure of this, is the length of the line segment is 2 meter, then 2 meter will be the magnitude, and in this direction is from A to B. So magnitude, how the magnitude is given? Its magnitude is given by the length of the line segment AB, and the direction is from A to B, indicated by an arrow. Okay, so if I denote it, as I told you earlier, if I denote AB bar as small a bar, then magnitude is denoted by modulus of A bar, and modulus of A bar is nothing but AB, or simply just remove the arrow from small a, that will be represented by A, and A is the magnitude of the vector A bar. So tumalike mon koriba, যদি এটা ভেক্টৰ AB বাৰ দিয়া থাকে লাইন সেগমেন্ট বুজাবলৈ আমি জানো এন্ড পইণ্ট বুজাবৰ কাৰণে আমি ক্যাপিটেল A ক্যাপিটেল B ইউজ কৰোঁ সেই কাৰণে AB বাৰটোত তোমালকে যদি এটো AB বাৰ এটা ভেক্টৰ ৰিপ্ৰেজেন্ট কৰে আৰু সিম্বলিকে যদি তোমালকে স্মল লেটাৰ দি ইউজ কৰে এনেকে লিখিব পাৰা সো AB বাৰে যদি এটা ভেক্টৰ ৰিপ্ৰেজেন্ট কৰে তাৰ ABA that means the length of the line segment it's a magnitude of the vector AB bar বা এনেকেও ক'ব পাৰা A বাৰ যদি এটা ভেক্টৰ হয় A বাৰ ভেক্টৰৰ ম্যাগনিটিউডটো হ'ব স্মল a বা modulus of A. Hope you understand how to represent a vector. Next, you see, okay. Next, you see, suppose we are considering AB bar as a vector, that's the previous figure, the same, but it is a portion of the line L. This is a straight line. L is a straight line, like this dotted mark. L is a straight line, and if from a straight line, if you cut off a portion AB, then AB bar will be a vector, and that line from where the line segment AB bar is cut off is known as the support of AB bar. Here I have written, if a directed line segment AB bar is a part of the line L, suppose here we have a straight line, it is ending up to the both side arrow mark, that is a line, we can extend it in both the direction. From that line, if I cut off a portion AB, then that line from where AB is cut off, that line is known as the support of the vector AB bar. And the sense of the vector, what do you mean by sense? Sense of the vector is AB bar is from A to B. If I write down it as BA bar, then the sense of the vector is from B to A. Okay, so arrow is given from A to B, then the sense of the vector is from A to B, from initial to the terminal. But if I write down BA bar, then we understand that arrow is given from B to A. In that case, the sense of the vector is from B to A. Okay, so this is just a preliminary concept of vector. Then we will go to the different types of vector. So different types of vector. First, we are going to know about the zero vector. What is the meaning of zero vector? You see, a vector whose initial and a terminal point coincide. তাৰমানে য'ত start হৈছে ততে শেষ হৈ গ'ল। এটা যদি এটা point আছে A, here only the vector is completed. Okay, in that case it is called a zero vector. Coincide means একে হৈ যায়। A vector whose initial and the terminal point coincide is called a zero vector or null vector. It is denoted by 0 bar. So simply 0 will represent a magnitude. Okay, its measure is 0. But if I put a arrow above this 0 bar, that will represent a zero vector. And in the case of zero vector, the initial and the terminal point coincide. It means initial and the terminal point are same. যদি এটা vector য'ত start হয় ততে শেষ হৈ যায়, তেনেহ'লে সেই ভেক্টৰটোক আমি জিৰ' ভেক্টৰ বুলি কওঁ। Thus, if I consider a point as A bar is equal to 0 bar, B bar is equal to 0 bar. Here you see, initial point is A, terminal point is also A. So A bar is a zero vector. Similarly, B arrow, directed line segment B bar is also represent a zero vector, etc. And remember it, the magnitude of 0 bar is 0. That measure is 0. Okay. And you see, 0 bar, it's a very important thing. That is what? 0 bar, zero vector cannot be assigned a definite direction. That means we cannot say that zero vector is, this is a zero vector, it will go this direction or this direction. You see the logo. If I put this like this, eneke disu jodi moi eneke jabo, na eneke jabo, na eneke jabo, etu moi kobo noaru. Why? Why it is not possible? As it is of zero magnitude, or it may be regarded as having the any direction. So zero bili kole etu jodi point hoy, etue point hobo. Ya কোনফালে গৈছে কথাটো নাহি হয় না নহয়। সো সেই কাৰণে আমি 0 বাৰক কোনো ধৰণৰ ফিক্স ডাইৰেকশন অ্যাসাইন কৰিব নোৱাৰো। যদি অ্যাসাইন কৰিব নোৱাৰো তেনলে আমি যিকোনো ডাইৰেকশন হ'ব পাৰে। সেই কাৰণে ইট মে বি ৰিগাৰ্ডেড এজ হেভিং দ্য এনি ডাইৰেকশন, এণ্ড বিকজ অফ দিছ ৰিজন all zero vectors are equal. Next we go to the next concept, that is your unit vector. A vector whose magnitude is 1 is called a unit vector. You know unit means 1. তো তোমালোকৰ যদি এটা ভেক্টৰৰ ম্যাগনিটিউডটো 1 হয় তাক আমি কি কওঁ? Unit vector. And unit vector means, or you can say like this, modulus. Modulus means magnitude. Magnitude of the vector AB bar, that is A is equal to 1. And you see, the unit vector in the direction of A bar is denoted by this symbol, and this is read as A cap. তোমালোকৰ এটা ভেক্টৰ যদি A bar দিয়া থাকে, তাৰ ডাইৰেকশনত তোমালোকৰ যদি ইউনিট ভেক্টৰ দেখিব লাগে, হেতু তুমি A cap দি ৰিপ্ৰেজেন্ট কৰো। আৰু তোমালোকক মই এটা ডেফিনেশন দি দিছো। A capৰ ডেফিনেশন টু হোল, or A cap যদি আমি উলিয়াব লগা হয় ভ্যালুটো, A cap we can find out by using A bar divided by magnitude of A. We'll discuss it later. আমি কেনেকৈ পালো এটো পিছত গম পাম। তোমালোকে সিম্পলি মনত ৰাখা, যদি এটা ইউনিট ভেক্টৰ উলিয়াব লগা হয় আমি ভেক্টৰটো তাক ম্যাগনিটিউড দি ডিভাইড কৰি দিলে ইউনিট ভেক্টৰটো পাই যাওঁ। Or you may write down like this, A cap is equal to A bar. Modulus of A bar may be written as A. Okay, so A cap by A bar by A, or by cross multiplying the vector can be find out if you know the vector magnitude of the vector and the unit vector. Okay, so A bar can be written as A cap. So here also some important things are there. The unit vector in the direction of positive direction of x-axis, y and z-axis is denoted by I cap, j cap, k cap. It is frequently used notation. So if I consider the three-dimensional geometry x, y, z in the direction of positive direction of x-axis, y-axis and z-axis, the unit vector assigned, that means how to assign the unit vector, they are represented by symbolically small I cap, small j cap and small k cap. Okay, and here's one more thing, as in the case of zero vector we have got all zero vectors are equal, but all unit vectors are not equal. And why not equal? As it may have different direction. No doubt unit vector measures bura সমান হ'ব। তুমি পিছত পাম ইকুৱেল ভেক্টৰটো কি জানিলে মই তোমালোকক এটা কৈ থৈছো। আমি জানো যে ইউনিট ভেক্টৰৰ ম্যাগনিটিউডবোৰ একে, কিন্তু ম্যাগনিটিউড একে হ'লেই তোমালোকৰ ভেক্টৰটো সেম নহয়। উইল গট ইট লেটাৰ। আমি পিছত পাম যে ইকুৱেল ভেক্টৰ মানে কি, ম্যাগনিটিউড আৰু ডাইৰেকশন দুইটা একে হ'ব লাগে। ইউনিট ভেক্টৰৰ ম্যাগনিটিউডবোৰ একে, কিন্তু ডাইৰেকশনবোৰ ডিফাৰেণ্ট। ইট মে হ্যাভ ডিফাৰেণ্ট ডাইৰেকশন। ফৰ এক্সাম্পল হিয়াৰ XYZ directions are different. So তেনেহ'লে তোমালোকৰ all unit vectors are not equal. Okay, so after that the next concept or next type of vector is co-initial vector. From the name itself is clear. Co-initial, that means initial point is same. So two or more vectors having the same initial point are called co-initial vector. That means if you consider two or more vector and their starting point is same, then they are known as co-initial vector. For example, this one. Suppose here I considered a vector AB bar. If this A is the initial point and like this. AC bar here, AD bar like this. So AB bar, AC bar, AD bar. That means a directed line segment AB, AC, AD. This way, AB, BC, AD are co-initial with initial point A. That means starting point to jodi eke hoy vector or. Those vectors are known as co-initial vectors. Next, again a new very important concept, that is your equal vectors. That means when we call two vectors are equal. Two vectors A bar and B bar are said to be equal. It satisfies these two conditions. Modulus of A bar is equal to modulus of B bar. It means the magnitude of the vector A and B are same. They have the same magnitude. Tar manbur eke hobo lagibo. And one more condition, that is what? A bar and B bar have same direction regardless of the position of the initial point. তোমালকে ভেক্টৰ কিটাৰ ইনিশিয়াল পইণ্ট বেলেগ হ'ব পাৰে, কিন্তু সিহঁতৰ যদি ডাইৰেকশ্যনটো একে হয় আৰু ম্যাগনিটিউডটো যদি সেম হয়, টু ভেক্টৰ্স এ বাৰ এণ্ড বি বাৰ ইন দ্যাট কেছ উই কল আৰ ইকুৱেল. আমি ইকুৱেল বুলি কেতিয়া ক'ম তেনেহ'লে ভালদৰে মনত ৰাখিবা, সেইটো হৈছে যদি দুটা ভেক্টৰৰ ম্যাগনিটিউড একে হয় আৰু সিহঁতৰ ডাইৰেকশ্যনটো সেম হয়. ডাইৰেকশ্যন সেম হ'লে এনেকুৱা কথা নহয় যে এটা ইনিশিয়াল পইণ্টৰ পৰা ষ্টাৰ্ট কৰিব লাগিব, এনেকুৱা নহয়, বা এটা লাইনতে থাকিব লাগিব, regardless of the position of the initial point. So in that case we call the vectors A bar and B bar are equal, and symbolically they are denoted by A bar is equal to B bar. Let me see in the diagram. Here A bar and B bar, these are two vectors. You see their magnitude, length of the line segment are same. Okay, A the line segment or length B hote সমান আৰু সিহঁতৰ ডাইৰেকশ্যনটো একে, দেখিছা না, এটো এনেকে গৈছে এটো এনেকে গৈছে, প্যাৰালেল হৈ আছে. So তেনেহ'লে A bar and B bar are equal vectors. Similarly here also AB, BC, CD. ইহঁতে চোৱা AB is to measure, BC measure to same, CD measure to same, and the direction to একে. গতিকে AB ইয়াতে AB bar, BC bar, CD bar are equal. মই তলতে লিখি দিছো ইয়াতে চোৱা হ'ব. তাৰপিছত নেক্সট হৈছে আমাৰ কনসেপ্টটো প্ৰপাৰ ভেক্টৰ. Proper vector means simple concept. A non-zero vector is called a proper vector if a non-zero vector, non-zero, যদি তাৰ ভেক্টৰটোৰ মেজাৰটো ম্যাগনিটিউডটো যদি non-zero হয়, জিৰো নহয়, ইনিশিয়াল টাৰ্মিনেল পইণ্ট একে নহয়, তেনেহ'লে তাক আমি প্ৰপাৰ ভেক্টৰ বুলি কওঁ. তাৰমানে জিৰো ভেক্টৰটো নহয় আৰু জিৰো ভেক্টৰ নহ'লে বাকীবোৰক আমি কওঁ প্ৰপাৰ ভেক্টৰ. ইনিশিয়াল এণ্ড টাৰ্মিনেল পইণ্ট ডিফাৰেণ্ট. Thus, if A bar is a proper vector, then modulus of A bar is not equal to 0. যদি প্ৰপাৰ ভেক্টৰ হ'লে কি হ'ব লাগিব? সিম্পল কনসেপ্ট, তাৰ ম্যাগনিটিউডটো 0 হ'ব নোৱাৰিব, আৰু ম্যাগনিটিউড 0 মানে জিৰো ভেক্টৰ, যাৰ ইনিশিয়াল আৰু টাৰ্মিনেল পইণ্টটো একে হয়. তোমালোকৰ কিন্তু ডেফিনেশ্যনছবোৰ ইম্পৰ্টেণ্ট. আমি যেতিয়া প্ৰব্লেমছ কৰোঁ ডেফিনেশ্যন প্ৰত্যেকটা আমি ইউজ কৰিব লগা হয়. Next, it's a very important concept, that is what? Your collinear vectors. That means when we call two vectors are collinear. Two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitude and direction. So collinear হ'ব লাগিলে কি হ'ব লাগিব? তোমালোকক যদি এটা লাইন দিয়া থাকে আৰু প্যাৰালেল সাপোৰ্ট বুলিও ক'ব পাৰা, লাইনডালৰ পৰা জোৰ পৰা কাটিছে, এডাল লাইনৰ লগত যদি সিহঁতি সেম collinear হ'ব, প্যাৰালেল যদি হয়, এটা same লাইনৰ যদি parallel হয়, they are called collinear vectors. For example, here you see A bar, B bar, C bar, these are your collinear vectors. You see here the magnitudes are not same, their directions, A bar and B bar have the same direction but magnitude are different, but A bar and C bar has different direction. But all of them are parallel lines. That means if here like this a line is there, all the vectors A bar, B bar, C bar are parallel to that particular line. In that case, they are said to be collinear. So collinear hobo lagile amar ki hobo lage? Only parallel hobo lagibo to the same line. Irrespective, this is very important, irrespective of the magnitude and direction. Because magnitude eke hobo na lage, direction eke hobo na lage, hole to bhal kotha baru hoboi, kintu tumalkor ki hobo lagibo? Parallel, edal line or parallel hoboi lagibo. So in figure, A bars, B bars, C bar are collinear. Okay, one more thing. If we have, these are collinear vectors, if the collinear vectors have the same direction, suppose A bar and B bar, ইহঁতৰ parallel হয় আৰু কি হয়, direction to একে, they are called like vectors. And if the direction is opposite, then they are said to be unlike vectors. So in figure A bar, B bar, C bar are collinear. Collinear vectors having the same direction are called like vectors. In figure A bar and B bar are like vectors. And collinear vectors having the opposite directions are called unlike vectors. In figure A bar and C bar are unlike vectors. So can you say what about this equal vectors? Equal vectors hole collinear hobone? Obviously yes. Karan equal vector hole magnitude same hobo. আৰু তোমালকৰ ডাইৰেকশনটো একে হ'ব লাগিব হয়নে ডাইৰেকশন একে হলেই তো হৈ যায় গটিকে তোমালকে ক'ব পাৰা যে all equal vectors are collinear but all collinear vectors are not equal. That's very important for short question. Next we have to know about the negative of a vector. So what do you mean by negative of a vector? Let A bar be a given vector, then the vector whose magnitude is same as that of A bar but direction is opposite to the vector A bar is called negative of A bar and it is denoted by minus A bar. That means if you consider, suppose this is a vector A bar, one more vector suppose I have considered like this whose direction is opposite to A bar. A bar eneke goise completely ulta ke ahise. Tetia A bar minus A bar, this is noted by minus A bar. Minus A bar is the negative of A bar. What does it mean? Negative hobo lagile amar ki hobo lagibo? Magnitude to same hobo lagibo but direction is completely opposite. So negative vector equal hobo janu? Obviously not. But negative vectors are collinear. So if I consider that suppose A bar is equal to AB bar, then what is B A bar? B A bar to minus A bar to kor pa start se B pora. So minus A bar is equal to B A bar. So you remember here as a note I have written here, modulus of A bar is equal to modulus of minus A bar. দুটাৰ ম্যাগনিটিউড সমান হ'ব কিন্তু A bar আৰু minus A bar ভেক্টৰ দুটা সমান নহয় কিয় নহয় because they have opposite direction আৰু AB bar কাৰ সমান তেনে হলে minus B A bar সমান AB bar B A bar সমান নহয় কিন্তু minus B A bar দিয়াৰ লগে লগে ডাইৰেকশনটো আকৌ উল্টা হৈ গল B A bar ইয়াতে আহে তো minus দিয়াৰ লগে লগে উল্টাকে যাব সো সেই কাৰণে আমি ক'ব পাৰো AB bar is equal to minus B A bar. So today I stop here. You try to remember or clear the concept of the terms of the vector used properly. Okay? So thank you.